managing SQL Server databases. So, who here is like, the most powerful things we have is the ability to clone. Most of us understand we have many, many different copies of systems. We have production, but we also have the development process where we do patching, testing, QA, whatever, and how to refresh those. That takes a lot of time from a SQL Server DBA perspective of what to do and how to do that. So we're going to make a clone of databases to show how fast I can make copies of databases for you. And then we're going to go into basically all the metrics and performance-wise and how I can show great detail and granularity for performance for each SQL server. So we're going to play with today. I've got two servers here. I have my past dev server and my prod server. So I have my production database, this one right here, AdventureWorks Data Warehouse. It's not a very big database overall, but it's not bad. It's small size. This one's right around 500 gig in size. So a decent sized chunk of data. On my dev server, I have one already here. Okay, we're not going to play with that one, but I don't have a Explore database here. So I'm going to go make an Explore database. Hold on for a second. All right. Much better. Interesting. Okay, that's much louder. All right.
That's
so we're
loud
going to
now.
here. I know.
Okay.
Check one, check two, test. All right. So I don't have a VMware Explorer database over here. And just to show I'm not cheating, because you can hide things in SQL Server without doing refreshes. So I'm going to do a refresh. Make sure, hey, look, there's not an Explorer database. So I go into Tinted Global Center. That's the wrong one. I have multiple copies. So I go to my Global Center here. And this is basically our management plane for all of our storage appliances. This is how you do everything in the central console. I have a databases tab, which I'm already at. And this shows all my databases in my environment. Hash prod. The one we looked at was AdventureWorks Data Warehouse. I just right click on it, actions, and clone. This clone is I need 4 pieces of information. I need a new name for it. I'm going to call this one Explore. Come on, let me type in here. Explore clone. I use the word clone here because I have scripts in the background that automatically clean up my old clones because I do a lot of demos and I get a lot of clones. So I'm going to take a new storage snapshot. This is a database level snapshot. It only affects one database. It's not a volume or a data store. It's only affecting the one database, and I can do snapshots all day long on this. And then, of course, where do I want to put this database? In this case, I want to put my dev server. And then SMB is how we do things under the covers, and I've got to put basically a file location for the new files. So the clone is going to actually make copies of all the new files. So I pick a place, and this is my dev share, which I put all my files at. I click clone. I theme the song of Jeopardy, but before I get started, it usually finishes. All right, it's done. It's a 500 gig database. I just made a non-production copy so the developers can go use. So we go back in the SQL Server. On my dev server, right click and choose refresh. I have an Explore clone database. This is a full working copy running at the same speed as production. So with this utility, all your developers who do database work, all your non-prod systems, we can get things going that fast. Oops. They can make copies as fast as they want to and often as they want to. Plus, we can do this via PowerShell scripts and or inside of our management plane, we have a database role. So you can give the database administrators access to the storage system to solve their own problems, do their own work, and stop bugging you, which is the most important part here. So for us, it's basically finding out who's doing the work and putting that work onto the person who's trying to consume the work. Instead of having to wait for someone else to do a task, have the person who needs it done do it themselves. But of course, have proper security so they can't screw everything else up. That's the amazing thing about this. So now, troubleshooting-wise, that's the next thing I'd like to talk about. So here, all managed objects. If you don't know much about the VM store itself, what we do is we do VM-aware storage. So each object here is either going to be a database or a virtual machine. So we can control everything at that level. So no more service policies where I have different group configurations to do management stuff. I can just scroll over and you see, I have databases and virtual machines all mixed into here. Well, I can go see which ones are using which resources, i.e. get tickets about things that are running slow in general. First thing I do, come in here, I sort by latency. what in my environment is running slow? Oh, hey, look, I have this database. Happens to, oops, let me scroll over properly. You know, this database here is a database. I know because of the name, but I scroll over to see it. Come on. You know, is running. I have a lot of latency. 23 milliseconds of latency is very bad performance for storage these days, and extremely painful for that. The cool thing is, again, I can hover over and figure out where the latency is coming from. So I'm now troubleshooting, trying to figure out what's going on here. We are a file-based storage solution, meaning when a data packet or an IO request goes onto the network, the server, the SQL server or VMware host has a timestamp on the data packet. When I receive that packet, I know when I got it. I know how long it took to get from point A to point B. So I can tell you your problem for this for a database is actually going to be coming from my network. In my lab, I have an old slow switch, and I can overdrive my processors in it, so I get a lot of storage network issues. I also hover over, I can see now breakdowns inside of my storage cache layers. So my flash here, this is basically my storage cache. I know I'm overdriving it right now because our goal is to have this under 1 millisecond or less. This box happens to be a hybrid, so it's got a mixture of spinning disks and SSDs in it. So pretty good at 1.3 milliseconds of latency on a hybrid system. You know, some of the other ones here, where my all flash systems don't have those kind of weird rates. Because you see here, I'm obviously running 300 mega throughput on this database, and my latencies are much, much lower. Versus here, I'm only doing 100 meg, and I've got good, bad latencies. But again, troubleshooting big picture, I can see things in seconds that normally would take you minutes, if not hours, to go through from a typical storage solution process. Let's just go dig in on these things a little bit too now. Under metrics, I can go configure and look at metrics per database over periods of time that I want to. So defaults 1 day. I really hate using IOPS because an IOP is not, all IOPS are not equal. I tend to use throughput for discussions because I want to see what my performance is over time on that. And then of course, you know, my latencies. Again, I'm doing this per individual SQL Server database. So when we do an application upgrade and performance sucks, I can go in and see what was that database performance before that, before the upgrade, and then after. Did something change? You know, and I can see all the different metrics. Now, obviously the yellow here is my reads, my blue is my writes. I can see that broken out. I have regular IOPS and then normalized IOPS. So the regular IOPS shows me how much individual IO transactions are going. The other one basically shows me normalized, making everything an 8K IOP. Because the SQL Server, most of your IOPS are going to be 64K in size. So that adds up really, you know, so a few IOPS takes up a lot of storage capacity. And then throughput. All right, troubleshooting is fantastic. So now let's go back to the database and stuff. Talk about space utilization and concepts of that. So that clone we made, you know, that was a 500 gig database. I put it on this past dev server. Let's go down to Explore database. You see here that 500 gig database is using 64 meg of space on my system. That is because I made a 100% copy of it. So I did the cloning process. So obviously, if I do writes to them, they're going to diverge and grow. But this way, if I had a 2 terabyte database with deduplicate compression, it tends to use about 500 gig of storage on stick. I have 10 developers. I make 10 copies. Guess what? I'm only using 550 gig usually. So I got about 50 gig of storage space to have 10 development working copies. That means I can now enable all my developers, all the people doing work, to have a full sandbox to play with. And when they have a full sandbox to play with, they write better code, they do better activities, and those type of things. And so the amount of space savings, because now, for example, one of my customers, they have a 2 terabyte data warehouse. They used to share one environment. Now they have 13 environments in the same amount of space. If they had to go buy all that storage, instead of having to buy 26 terabytes, they only have to buy 2 terabytes. Lots of cost savings from that. So we're much more efficient when I do the cloning from Tinted. If I did a backup restore process, you won't get the same dedupe compression because in a SQL Server, each data page will have a different ID on it. So the dedupe and compression process, your compression still works, but your dedupe will fail because the IDs are different. So with the cloning, everything's the same. So I get fantastic processes. So I go back to my management plane here, all my databases. I'm going to add a field. That's my filter button. I didn't want to do that one. The live logic footprint and my space savings factor. Hide this. I mean, these numbers are, okay, this one's a cheat one. This is actually a database log file that I cheated with. But, you know, I have many of them in the 10,000 times your compression ratios. It is easy to get things into the hundreds of percent of hundreds of times compression because of our cloning process. And that's what makes this so unique is you have a lot more databases. You can solve a lot of the problems your DBAs use with this. And the goal of our process with this is to make the administrators, the admins, the ones doing the work, to be now part of the innovation process of your organization. No longer just a cost center or an impedance to them getting their work done. We're now enabling them to do more things by we're providing the tools to them. All right, well, that's all I have for today. Laura, where'd you go? Okay, it is time for a drawing. And thank you for your time. Actually, is there any questions first before I go there? I can't hear you, sorry. Okay. Yeah, sounds good. We'll do it afterwards.
Oh, okay.
Yeah.
All right. Thank you, Sean. Let me do my thing here.